What if I told you that AI just broke the sound barrier for language models? A new model called Mercury 2 is generating over 1,000 tokens per second. That's not a typo. 1,000 tokens every single second. And that's just the beginning of today's news. We've also got DeepMind solving mathematical problems that have stumped humans for decades, Perplexity launching a multi-agent system that can run for months, and OpenAI revealing their secret hardware project with Apple's legendary designer Jony Ive. This is AI News Shrimpy, and you're watching the future unfold. Let's start with what might be the most technically significant announcement this week. A company called Inception Labs has just released Mercury 2, and it's completely rewriting the rules of how fast AI can think. Here's the headline number: 1,009 tokens per second on NVIDIA's latest Blackwell GPUs. To put that in perspective, most large language models today generate maybe 50 to 100 tokens per second. Mercury 2 is doing 10 times that. But the really interesting part isn't just the speed. It's how they achieved it. See, every AI model you've used, whether it's ChatGPT, Claude, or Gemini, they all work the same way. They generate text one token at a time, left to right, like a typewriter. Token, wait, token, wait, token. Mercury 2 throws that entire approach in the trash. Instead of autoregressive generation, Mercury 2 uses something called diffusion. Now if you've used image generators like Stable Diffusion or Midjourney, you've seen this before. Those models start with noise and gradually refine it into a coherent image. Mercury 2 does the same thing, but with text. Think of it like this: instead of writing a sentence word by word, Mercury 2 starts with a rough draft of the entire response and then refines it in parallel. Multiple tokens at once. The whole thing comes into focus simultaneously, like developing a photograph in a darkroom. The implications for production AI are massive. Modern AI applications aren't just one prompt and one response anymore. They're loops. Agents running retrieval pipelines, chaining API calls, retrying operations. In those loops, latency compounds at every step. If each step takes half a second, and you have 20 steps, that's 10 seconds of waiting. Mercury 2 cuts that dramatically. And the pricing? $0.25 per million input tokens, and 75 cents per million output tokens. That makes it one of the cheapest reasoning-capable models on the market. NVIDIA's own Shruti Koparkar said this demonstrates what's possible when new model architecture meets NVIDIA AI infrastructure. Companies like Zed, the popular code editor, and OpenCall, which builds voice AI, are already integrating it. Mercury 2 is particularly good at three things. First, coding autocomplete and real-time suggestions where any pause breaks the developer's flow. Second, agentic workflows that chain dozens of API calls per task. And third, voice interfaces where latency budgets are measured in milliseconds, not seconds. Max Brunsfeld, co-founder of Zed, said, "Suggestions land fast enough to feel like part of your own thinking, not something you have to wait for." This is a big deal. Diffusion models for images have been around for years. But applying diffusion to language models? That's new territory. And if Mercury 2's approach scales, we might be looking at a fundamental shift in how AI inference works. The autoregressive paradigm has dominated language models since GPT-1. Mercury 2 is the first serious challenger. From speed records to mathematical breakthroughs. Google DeepMind has unveiled Aletheia, an AI system that's solving problems that have stumped mathematicians for decades. The name Aletheia comes from the Greek word for truth or disclosure, which is fitting because this system is uncovering mathematical truths that humans couldn't find. Aletheia achieved 95.1% accuracy on the IMO proof benchmark. That's the International Mathematical Olympiad level problems, the hardest competitive math challenges that exist. These are the problems that the smartest high school mathematicians in the world train years to solve. Aletheia handles them with ease. But here's what really caught my attention. Aletheia didn't just solve textbook problems. It tackled open problems posed by the legendary mathematician Paul Erdős. If you're not familiar with Erdős, he was one of the most prolific mathematicians in history, publishing more papers than any other mathematician. He had a famous tradition of offering cash prizes for unsolved problems, ranging from $25 to thousands. Some of these problems stood unsolved for 50 or 60 years. Aletheia solved 2 of them. Let that sink in. Problems that the entire mathematics community couldn't crack for half a century, solved by an AI. The system uses something called a generator-verifier-reviser loop. First, it generates a potential proof. Then it verifies whether the proof is mathematically valid. If it finds a flaw, it revises and tries again. This iterative approach mirrors how human mathematicians actually work, going through draft after draft of a proof. Except Aletheia can do thousands of iterations in the time a human takes to write one line. What makes this different from previous math AI? DeepMind's earlier systems like alpha geometry and alpha proof were impressive, but they focused on specific problem types. Geometry problems, or certain competition formats. Aletheia is more general. It can handle number theory, combinatorics, algebra, and formal proofs across multiple mathematical domains. It's not a specialist. It's approaching mathematical generality. DeepMind says this represents a step toward AGI-level mathematical reasoning. Whether you agree with that assessment or not, there's no denying that AI is now operating at the frontier of human mathematical knowledge, not just learning what humans discovered, but discovering things humans couldn't. The real question is what happens when we point these systems at the Clay Millennium Prize problems. Those carry $1 million reward each. Problems like the Riemann hypothesis and P versus NP. Could AI claim one of those prizes before a human does? We might find out sooner than anyone expected. Perplexity has entered the agentic AI race with something called computer. Yes, just computer. And the concept is ambitious. Computer is a system that can run for hours, days, or according to Perplexity, even months end, executing complex multi-step workflows. Here's how it works. You give it a goal like, plan and execute a local digital marketing campaign for my restaurant, or build me an Android app for my research workflow. Computer then breaks that down into subtasks and assigns them to multiple AI agents running in parallel. What makes this interesting is the multi-model approach. The core reasoning engine runs on Claude Opus 4.6 from Anthropic. For deep research tasks, it uses Gemini. Image generation goes to Nano Banana. Video production uses Veo 3.1. Lightweight speed-critical tasks go to Grok. And for long context work, it routes to ChatGPT 5.2. Each model handles what it's best at. This is different from competitors like Claude Cowork, which only uses Anthropic's own models. Perplexity is basically building a conductor that orchestrates an entire orchestra of AI capabilities. Every task runs in an isolated cloud environment with access to a real file system, a real browser, and real tool integrations. It's available now for Perplexity Max subscribers. The article I read actually mentioned OpenClaw as a predecessor to this concept. OpenClaw runs locally on your machine with ambient, persistent AI assistance. Perplexity Computer takes a similar philosophy but moves everything to the cloud with enterprise-level integrations. We're seeing the emergence of AI operating systems. Not just chatbots you talk to, but systems that actively manage workflows, coordinate resources, and execute multi-day projects. Whether that's Perplexity Computer in the cloud or OpenClaw on your local machine, the direction is clear. AI is becoming infrastructure, not just an interface. Our final story takes us into OpenAI's hardware ambitions. The information has revealed new details about what Jony Ive's team is building with OpenAI, and it starts with a smart speaker. Yes, the designer who gave us the iPhone, the iPod, and the AirPods is now working on an AI-powered speaker. But this isn't just another Echo or HomePod. The device has an integrated camera with Face ID-style facial recognition. It can observe users and proactively suggest actions. In an internal presentation, OpenAI showed the speaker suggesting an early bedtime when it knew the user had an early morning meeting. It will support purchases, voice requests, and deep contextual awareness of your environment. The price point is between $200 and $300, with a launch targeted for February 2027. Beyond the speaker, OpenAI is exploring a smart lamp and smart glasses, though those products won't be ready until 2028 or later. Now here's where it gets interesting. Jony Ive acquired his hardware company I/O in May 2025. In November, Ive and Sam Altman described their prototype as peaceful and an active participant that's not annoying. They want it to make people feel joy. Altman even called it the coolest piece of technology that the world will have ever seen. Big words. But behind the scenes, there's apparently tension. Love from Ive's design company remains separate from OpenAI. OpenAI engineers have to translate Love from's designs into actual products. And there are complaints about Love from's secrecy and slow design revisions. The team includes former Apple employees like Evans Hankey, Tang Tan, Scott Cannon, and even Adam Q, son of Apple's Eddie Q. It's basically an Apple reunion tour building AI hardware. Whether this becomes the next iPhone or the next iPod Hi-Fi remains to be seen. But OpenAI clearly believes that the future of AI isn't just software. It's hardware that lives in your home, watches what you do, and actively participates in your life. Some people will find that exciting. Others will find it terrifying. Probably both are correct. And that's the AI news for March 5, 2026. Mercury 2 shattering speed records with diffusion language models. DeepMind's Aletheia solving decades-old math problems. Perplexity launching an AI workforce that can run for months. And OpenAI building hardware with Jony Ive. The pace isn't slowing down. Every week brings something that would have been science fiction a few years ago. Thanks for watching AI News Shrimpy. If you found this useful, consider subscribing and hitting that notification bell. I'll see you in the next one.